Hello everyone. We just finished Earth's layers and now we are going to do Earth's plates. So I'll read the document and then maybe you follow through with this. Again, we are still in the Earth's layers. We are just moving to another small subtopic, which is Earth's plates. The crust and the outermost solid part of mantle. So crust and outermost solid part of the mantle is called lithosphere. So when you say, so most of the kids, when I was teaching, they asked me, so these questions are going to come. So yes, I would specify the questions that might come. I'm not sure because at every year the teachers change their questions. It's not how I memorize them, it's how much you know the concept. So when you know the concepts thoroughly, it's very rare that you miss a question. So do not memorize for the sake of memorizing it. Understand what the Earth's crust is about and how the Earth's plates work, what is lithosphere. So so when you learn it in such a way that you are actually understanding the concepts, any test, any quiz will always be aced. Okay, so don't worry about what kind of questions are going to come. Instead, think how much knowledge I'm gaining from the documents that I'm reading. Okay, and as a sixth grader, it's always better to understand the concepts and further move on, because as you go to seventh, eighth, and so on and so forth, it'll always add on to the knowledge that you know, rather than, oh, I memorized it and I'm not able to recollect what that is. Okay, and I know everybody can do it. If you study, if you just take a few minutes just without distraction, you will get it done. Okay, so let's go move forward. So the crust and the outermost solid part of the mantle are called lithosphere. Earth's lithosphere layer is broken into pieces known as tectonic plates. So tectonic plates are just, again, layers of the earth that are actually broken down into plates. The word tectonic comes from a Greek word tektonikos, which means builder. Again, that is good to know. When if you have a quiz bowl, or any knowledge quiz that has been conducted by the state or by the county, and you are one of the participants, it is nice to know the word tectonic comes from the Greek word tektonikos, which it's nothing but builder. Okay, so Earth has about 12 large plates and many small plates of different shapes and sizes. So again, tectonic plates are nothing but big, big chunks of land, which is being broken down. So there are many. How many of them are there? At least 12 large plates of tectonic plates are there, which are of different shapes and sizes. Okay. So yes, that could be one of the questions that can come. What is a lithosphere? So that is another question that can come. Okay. So I'm just giving you, I'm not for sure it's definite or not, but these are the questions as you read. If you have a notes and you have a habit of taking notes, make sure that you take notes in a very clear page, put as a pointers. If you write a big paragraph, later when you want to come and review them, that's not going to happen. Nobody will take time. I know everybody wants to have the short crisp answer so that it's easy to find, right? So then please write your notes in such a way as pointers, so then when you want to read through, oh, I know this, I've written it down, you can color code them. Color code it. Maybe all the main words which are introduced in the chapter can be color coded as green, and then their definitions can be written as in different color, whichever you feel, and that is a color code that you have done for yourself, right? And it's easy to find your answers, it's easy to learn that way. This is just few things that I have done in my school when I was in school. This is few things I've done when I was in college. So having done that, organizing your stuff will be very essential as you go to higher classes. So that starts from sixth grade. When you're in elementary school, the teachers help you out to get the organizer or pointers how to do it. But when you are in sixth grade, they expect you to know these things. So start doing it. It's very essential, and it is also important for you to stay in track, so that your scores and your academics stay put and very and you have good score. Okay, so let's move on now. So Earth has about 12 large plates and many small plates of different shapes and sizes. Most of the Earth's plates are covered by water and not visible when viewed from outer space. So that is one of the important concepts. That is why we cannot see the plates, and because why? Because they are all covered by water. Tectonic plates. One thing about tectonic plates, as you go, you have, I don't know whether you have learned about Alfred Wegener. Alfred Wegener is the one scientist who has confirmed initially that these continents, or these all these plates, they actually connect together as a puzzle piece. But at that time when he just said his theory, nobody was ready to even listen to him, and it was considered a big joke. Okay, so tectonic plates actually fit together like a big puzzle piece and move around the earth's surface over a large period of time. Plates can move in three ways. Now, this is another very important concept. Plates can move in three ways. They can move away from each other, they can move towards each other, or they can slide and pass through each other. Okay, so that's another important thing. So what did we learn? We learned a lithosphere. We know what a crust is. We know we know what the term tectonic came from. We know what the word tectonicos mean, right? And then now we are moving to the concept that Alfred Wegener's theory was right. What was his theory? That all these different pieces can be different plates. When they come together, they're all getting connected as a puzzle piece, one single puzzle piece. So at that time when he was suggesting the theory, nobody took it seriously. Now that has been proven. So now again, the plates can move in three directions. They can either come towards each other, away from each other, or past, slide through each other. Okay. Some plates are made up of continental crust, which is the land that makes up the continent. So obviously continental crust, meaning that the crust is made up of land. Okay. So, and this accounts for about 40% of Earth's surface. Continental crust is older, thicker, and less denser than oceanic crust. So there are two types of crust. One is continental, which means land-made crust, and the other one is oceanic crust, which is less denser. Continental crust is always thicker and older, while oceanic crust is less denser. Oceanic crust is over 60%, which means it's more than continental crust. And then the type of crust makes up the floor of the ocean and is thinner and denser than continental crust. So oceanic crust is always thinner and denser than the continental crust. Okay. Oceanic crust is constantly produced in some place of the ocean floor. So oceanic crust is under the ocean and it's constantly getting produced each and every day. Okay. So magma rises through the cracks and cools and forming new crust. So how does it happen? That the magma, the lava, it moves up and rises through the cracks, and then it forms a new crust. Again, this process keeps repeating and repeating. Did you see here? See, this is Australia, this is India here, right? South America. So all these, at one point, they were all connected. So this was what Alfred Wegener's theory was. He said that everything is connected at some point. It was connected at some point. He'd say this is North American plate, Pacific plate, right? Now, Earth's landforms. Continental drift, the continents drifted apart continuously in slow motion. Now, when you ask, hey, so these continents, did they get drifted in 1 day, 2 days? No, all this happens, landform forming, different varieties of landforms happening, like mountains, mountain ridges. All this does not happen in a day or two. It happens over a process of decades. Okay, so Earth's landforms. Continental drift apart continuously in slow motion. One of its effects may be the creation of landforms. So they drift apart continuously. So they always, continents, when they start moving, they drift apart continuously in a very slow motion. One of the effects that may be creation of landforms. So in this process, what happens? They are either creating different varieties of landforms. What is meant by actually continental drift? If you ask, somebody asks, what is it? What are you talking about continental drift? What does it mean? In past, many people thought that Earth's continents remained in the same place and did not move. But in early 1500s, explorers started to notice that continents of Africa and South America looked like they might fit together. So See how things are moving. Earlier, when Alfred Wagner had introduced the concept saying that these look like puzzle pieces and they are actually connected, nobody listened to him. And then eventually everybody started exploring. So in 1912, a German scientist named Alfred Wagner proposed that about 200 million to 225 million years ago, the continents were connected together. And he named it something called as Pangea. So what is Pangea? According to Alfred Wagner, continents were connected together, and then he used the word for the connected thing called as Pangea. Wagner's theory that Pangaea broke apart and shifted to form continents as we know them today. This theory is called continental drift. If somebody asks, what do you mean by continental drift? Or if you want to explain someone, what is a continental drift? Continental drift is nothing but drifting of the continents from from their position to a different position. Okay, it's called continental drift. Now, according to Alfred Wagner, what happened? In 1912, Alfred Wagner has suggested that all these continents can be clubbed together as a single puzzle piece. Okay, and that he named as Pangea. So you need to remember the word Pangea, you need to remember the word continental drift, and you need to explain who is the scientist who actually proposed the continental drift and the word name and framed the word Pangea. Okay? Wagner did not have any firm proof that continental drift had occurred, but several other pieces of evidence supported his theory. Rocks. So at that time, when he framed Pangea and had the concept of continental drift, Wagner did not have any proof to show the world or show the then scientist group that what he's saying was right. Okay, but as things moved on, rocks of the same age and type were found on the coastal lines of South America and Africa. So people found that there were certain types of rocks, there were certain types of fossils, there were certain types of plants and animals that were seen on the lines of South America as well as in Africa. So fossils of similar plants and animals were also found in other areas too. Ultimately, Wagner could not explain what kind of forces could move such large mass land across Earth, and many scientists rejected the theory. So, since Wagner could not explain in detail, though he understood the concept, though his theory was right, he could not prove. You know, as a scientist, we need to prove our observation. We need to find the way to analyze the theory that we have behind it, right? So here he could not prove how to explain the then scientist group, whether these pieces can be fit in, and if it fits in, how is that you have how can you explain that, right? So that and then it was ultimately Wagner he could not explain, and hence it was rejected. His theory was rejected. So now we have to move on to see the spreading ocean bottom. So in 1950, technology was developed that allowed scientists to map the ocean floor. So at this point, we will stop, okay? And till this, I need everyone to just review once again, go back and review it. I've explained it very slowly and clearly. So the sea floor spreading and the ocean bottom and the proof of continental drift we'll talk about in the next slides, or in the next video. Okay, right now I want you guys to go back and review this once again so that the concept is clear and those terminologies are also clear for you. Okay, thank you.